Hello, my name is Alan Rose from Corrdesa, and today I'm going to talk to you about our non-drip anodizing and plating technology. Our equipment can be wheeled right up to the flight line, which enables repairs to be made directly on the airplane, avoiding substantial disassembly and saving significant time. Our mission is to help our clients quickly develop, qualify, design, and implement corrosion-resistant materials and coatings that meet regulatory requirements such as REACH, EPA, OSHA, etc. And what is unique by the way we do this is we leverage our engineering simulation expertise, which helps us to significantly reduce the time taken to qualify these materials and coatings. Our vision is to become a key company in this area and the company to consult for corrosion solutions. Some background on Corrdesa. Well, we're already experiencing transitioning and deploying new technologies. For example, as an outcome of another Navy SBIR, we actually developed and commercialized Corrosion Gin, an award-winning galvanic corrosion software tool for assessing galvanic corrosion risk. This has been released as a SaaS tool, that is software as a service, and this itself is a growing business model, highly scalable and monetized through licensing. So from a marketing perspective, we also teamed up with initially two organizations, a large multinational engineering company and also a global publishing house. And each of these licensing agreements extend our global reach, providing opportunity for significant growth. So we put a lot of effort into transition. We also have unique R&D experience, particularly expertise in the lab where we've developed material screening protocols. Indeed, one of our protocols was adopted by NAVAIR, the Naval Air Fleet, in order to standardize a process for consistent and robust measurement of polarization curves used to support the data acquisition needed for our upcoming revised military standard, MIL Standard 889D for dissimilar materials. We have developed many coatings and processes which have helped us to also hone our skills in framing, testing, and qualification programs. As I said, engineering simulation is very much a technology that we embrace. It gives us great insight and it allows us to assess and test innovative ideas, such as our new scalable electrode design, for which we have a patent pending. I personally have always been an advocate of engineering simulation capability. For aerodynamics, you consider simulation technologies as providing essentially a digital wind tunnel. And for our sector of materials development, we think of simulation as providing us with a digital corrosion test chamber that runs in a fraction of the time compared to a 40-day physical test. Our staff comprise a number of experts in their own field. Our CTO, for example, Dr. Keith Legg, has more than 35 years experience of qualifying new coatings, during which he played a significant role in hazardous coatings replacement technologies and replacing chrome. He is presently working with the Department of Defense on the reduction of chromates. Not only have we transitioned and commercialized a software product, we have also developed and manufactured and sold mobile non-drip plating equipment, and I'll tell you later about the ground support equipment that we've sold to Lockheed Martin's F-35 program. So, the Navy challenge. What they wanted was a portable, corrosion-resistant coating repair technology so that they could work directly on the aircraft, like on this picture. This capability would reduce the turn time for repairs on aircraft, improving readiness, while at the same time eliminating further risks to personnel from exposure to toxic materials. The Navy wanted this capability to be transitioned into the fleet readiness centers and used across all types of models and series of aircraft. Their expectation was that they would procure 3 of these developed systems for their main fleet readiness centers, North Island, Cherry Point, and Jacksonville, along with training. And the aim was for this to be done in 2021. Our solution, referred to as SETI, Selective Electroplating Technology Improvement, comprises a unique closed-loop electrolyte flow tool, a rectifier, and 2 pumps. One pump supplies the electrolyte flow to the tool, and the other pump essentially sucks back the excess electrolyte. So if you look at this photograph at the bottom right, you can see a close-up of the dualistic tool. You can see 3 holes in a platinized titanium anode, and these are normally covered with a porous pad, like a Scotch-Brite. So the electrolyte flows through these 3 holes and soaks the pad. Around this anode, you can also see an annular opening, which is in fact connected to the second, larger pump, which essentially sucks back excess electrolyte and also entrained air. So the IP in this design is essentially achieving a very delicate balance. The electrolyte is supplied at a rate just enough to soak the porous pad without causing it to drip. And then the second pump withdraws the excess electrolyte just at the right flow rate. Too much and the pad would be starved of electrolyte, and too little and the pad would drip. So when we look back at the traditional way of selective electroplating, that traditional way is essentially like Shakespeare using his quill, dipping the tool into a well of ink, or in our case, a container of electrolyte. Then as you take the tool to the part being repaired, you run the risk of dripping the solution where it isn't needed. Artisans can in fact spend a lot of significant time laying out material to gather the surplus of dripped electrolyte. All these pre-processing steps adding to the total repair time. Whereas using the dualistic tool, it's essentially equivalent to a ballpoint pen or a Sharpie, where all the electrolyte is contained within the tool and it doesn't drip. So this avoids contamination of nearby equipment and components. It reduces emissions, resulting in a much safer process for the technician. And its mobility enables you to take the anodizing or plating repair capability right up to the aircraft, avoiding substantial disassembly of any parts and saving a lot of time. And even if you could disassemble those parts, you would have to send them out to a plating shop, and that can take time. You just get in line with all the other parts awaiting repair. So Corrdesa has also developed multiphysics software models and a capability that enables us to design and simulate and optimize these processes. So we can quickly make tools for specific repairs by using 3D printing. And the result is that we've halved the anodizing time required for our first prototype tool. So the NavAir system is essentially TRL9, and we're already selling other similar commercial systems. Okay, in terms of our current status, we actually demonstrated very early on in our program in 2018 an initial prototype tool. Here in the photograph, you can see an anodizing repair being applied to a static port on the P8 Poseidon, which in fact was damaged by a lightning strike. This repair took about 25 minutes. The plane was brought into the Fleet Readiness Center at Jacksonville in the morning. We executed the repair and it flew out before lunchtime. There is a link to the Navy video of this demonstration on the Corrdesa website. After almost 3 years now, there is no sign of corrosion on the repaired static port. So where are we going with this technology? Well, here's our plan. After the initial demo, an objective was set for Corrdesa to design and optimize a new tool that will perform the same P8 repair but in half the time, and then conduct another demonstration on the P8. That was scheduled essentially for last year, and because of COVID, it has been pushed more and more to the right. However, we have in fact already designed and manufactured a new tool and tested it on the surrogate of the static port in our lab at Corrdesa, and indeed we've halved the process time. We're now just waiting for access to the Naval Air Station in order to do the demo on the actual plane. Our repair processes have been captured in the computer interface of our newly developed anodizing systems, so we will be able to deliver the units to the Fleet Readiness Centers just a few months after an order. In parallel with all this activity, of course, is the fact that we have continued to develop non-drip plating systems and have actually sold 50 specialized, customized units to the Lockheed F-35 program as standard ground support equipment, and they have an interest in a further 120 or more. There are other opportunities for specific tooling and repair design, such as on helicopters, so we're now seeking investments to expand on these areas. Why SETI? Well, First and foremost, it is a non-drip closed-loop system which avoids contamination of the plating area. So this reduces the risk of damage to adjacent components from unwanted drips. There are actually two pumps, one pump supplying the electrolyte and also a larger suction pump that withdraws excess electrolyte along with the ambient air. So this in fact reduces emissions, providing an added benefit that minimizes the PPE, personal protective equipment, required. Just simply gloves and goggles, resulting in a much quicker preparation and process time. We've also housed the anodizing plating system in a custom robust cart, enabling the repair to be easily brought up to the aircraft. And also we can use simultaneously several tools. So the operator can easily move from one process to the other, from cleaning, pre-process, anodize, and post-process treatments by simply moving through one tool at a time, which significantly reduces the total process time. So let's take a quick look at some other opportunities. Corrdesa is already engaged with the US Air Force to scale up this capability for spot anodizing repair on the floor of the C-5 cargo aircraft. The Lockheed F-35 opportunity is underway. In the photograph here, you'll see the mobile zinc nickel plating unit for repair of landing gear. The tools can be operated 20 feet away from the cart, and the tubes are protected by the spiral guard. I should note that it is not just sustainment. There are also opportunities with OEMs who have a need for touch-up when components are damaged during manufacture, rather than condemning the whole part and starting over again. Corrdesa now has the capability to simulate these non-drip processes, which enables us to quickly design and optimize new tooling systems, which can then be built very quickly with 3D printing technology. So to wrap up, if you have any questions, please feel free to reach out to me. Here are my coordinates, email and phone number. You can also reach our website address as well. And ask me any questions on how selective electroplating or anodizing can increase your aircraft repair options. Thank you very much.